Nuclear fusion has been the dream of clean energy for a long time, but it was always 2 decades away. Not anymore.
If you look at some of the literature recently, most of the time horizon, we're talking about like 5 years.
Another misconception about nuclear fusion is that even when it finally comes, it will mean massive multi-billion-dollar facilities. Not so. The future of fusion doesn't need to look like those giant reactors from the past, at all. In fact, the next major leap in nuclear energy technology actually fits on a tabletop or a closet. I've seen it. A private company called Alpha Ring is flipping the traditional script by focusing on microfusion. Instead of splitting atoms apart like today's traditional nuclear plants, they fuse them together to create bursts of energy. The beauty of this reaction is that it is completely radiation-free.
Actually, first of all, fusion itself is non-radioactive. So there's no radioactive concerns here, right? And secondly, the way we're doing fusion is called PB11 process. In that process, there are no high-speed particles going to be emitting as a byproduct of the fusion process. So the whole environment is totally non-detrimental to human beings. With our methodology, the only byproduct is high-speed alpha particle. And alpha particle can't even penetrate a paper.
That means zero greenhouse gases, zero long-lived radioactive waste, and no need for bulky and expensive radiation shielding. The truth is that making fusion work is not just a science problem anymore, it's more of an engineering and data problem now. Alpha Ring realized that controlling these tiny microreactions requires extreme precision. To solve this, they moved their experimental labs to Taiwan. Why? Because they want to tap into the world's highest density of semiconductor manufacturing and precision engineering.
Very interestingly, we figure that most of these technological breakthroughs takes semiconductor technologies. And Taiwan is a place that has the most density of the semiconductor companies and technologies in the world. That's why we actually have moved the experimental lab from the US to Taiwan. So we're kind of bringing the semicon industry over to new energy industry. And I think that process can actually create huge momentum in a new way of approaching this fusion process.
They have even built a fully functional educational model called Alpha E. It's already been installed at Purdue University in the United States and at Sofia University in Bulgaria, where students can now safely see and operate a real fusion process right there in the classroom.
I think Alpha E, E for education, of course, is actually a very good manifestation about how the technology is composed in our methodology. And the process can actually create fusion. So, it's going to be very, visible just by, students sitting around the classroom. They can actually see fusion happening, which is quite incredible.
They also have agreements with universities in Taiwan and other countries to deploy Alpha E as an educational tool for this generation, not the next, of physicists, engineers, computer scientists, and more. This micro-first approach completely changes how we generate and distribute power. Because these reactors are compact and incredibly safe, they are entirely free from the grid. Instead of losing 8 to 15% of power across miles of transmission lines, you could deploy a decentralized fusion reactor directly where it's needed, inside a hospital, a manufacturing plant, an AI server farm, or even a vehicle. And just 1 teaspoon of this fusion fuel holds the energy equivalent of a ton of coal. Look, we've all seen the news. We're in a desperate race for more energy, and the cleaner, the better. Basically, everything we do consumes energy, and we need more of it every year. Traditional renewables like solar or wind simply can't keep up with those insatiable demands. We urgently need an inexhaustible, stable power source that doesn't pollute the atmosphere and doesn't leave behind dangerous radioactive waste. Nuclear fusion fits the bill. So commercial fusion might not be decades away anymore. The transition to a post-carbon world won't come from one single giant scientific leap. It will come from a new constellation of small, safe, and modular machines. It is already clear that we need more energy for more things. There are different approaches to get that energy, and nuclear fusion looks like a promising one. I hope that gives you food for thought. If you like this video, please leave a comment below and subscribe to the channel. I really appreciate your support. See you in the next one.